researcher at National Center for Space Exploration Research and Case Western Reserve University. I'm a fifth-year mechanical engineering student. I've been researching on this fire blanket project for 15 months. We're studying fire blankets for structure protection. This is to protect the houses from impeding fire. The main goal of the fire blanket project, as funded by FEMA, is to find an adequate commercially available blanket to protect houses as fire fronts are approaching in the wild-urban interface. So as forest fires approach, the blankets are deployed, and if all goes well, the structure behind is completely protected. This saves billions of dollars in damage every year. Although the cost of the blanket may be high, it's much cheaper than most of the houses they will be protecting. Many of the houses in the urban interface area are well over hundreds of thousands of dollars. These blankets will be significantly less than that. Personally, I find this project fascinating because we are keeping firefighters safe from keeping them out of the urban interface during these fires. The more protection we can provide for houses, the fewer people are needed to protect these houses. I'm motivated by the project because we are helping firefighters stay out of the urban interface when it comes to fire season. When you deploy these blankets, it's usually much quicker than trying to force water into the urban interface or to try to find water sources because there aren't many in the desert where many of these fires are started. So the blankets are deployed as the fire front is approaching in the urban interface. So instead of having firefighters out there at all times to protect these homes, the firefighters can come in, do a fire line, keep it from approaching any further beyond the homes that are already protected. Today, the LA County Fire Department is running patterns during a mock forest fire. During this time, we'll be testing our fire blankets on the structure back here. We have 4 commercially available blankets that we're testing today from different manufacturers. We're collecting data from the temperature and the heat flux as the fire front approaches the structures. They're fully instrumented, and we have a data logger to collect all the information. Earlier today, we started all of our data collection for the fire. When we get the clear, the fire department will set fire to the bottom of this ridge, and the fire will progress up the hill. Because it's a type 4 fuel, this fire is probably going to go very quickly and burn very hot. Then after everything's cooled, we can go in and get our instrumentation and collect all of our data. After that, we'll be analyzing the data. This morning, I helped cover all the instrumentation and start the data system. During the fire, I'll only be observing, but after everything's cooled down, I will go in, collect all the instrumentation, collect the data, and then later tonight I will probably be analyzing it. From today's test, I hope to learn exactly what blankets work best in an actual urban interface fire. Because so far, we've done all of our testing in a research lab. So it's nice to finally get an actual fire. Case Western Reserve University was funded by FEMA's Assistance to Firefighter grant because we have a great combustion background for many of our mechanical engineers or engineering professors.
We've actually got several things going. It's a real cooperative effort between the U.S. Forest Service, LA County Fire, Case Western University, and some other independent organizations as well. And we've got several different tests that we're undertaking. The first one that we talked about here with the structure protection to test and evaluate different materials to protect structures in the wildland and urban interface. These are also used in remote locations. Forest Service, Park Service has historical cabins or facilities that we use the same materials to protect them as well. And then the other component here is to test different protection measures for dozers. We utilize dozers quite a bit to build fire line to protect structures and homes and other areas as well. And so we were looking at different ways, first of all, to protect the operators in the event of a burnover. If the fire impinges on that dozer, we've got some materials that are curtains that can drop down to protect them. There's also showers that deploy water within that. So that's part of this study. The other thing too is just to evaluate what the environmental conditions are inside that cab. There's all different types of materials there, plastics, hydraulic hoses, fluids, and so forth. So we've got sensors in there that can measure the temperatures and what types of gases are being put off by those different materials, and see how the glass and the curtains and those materials protect those operators and how they affect that environment. Well, it's primarily, we're on LA County land, and so as I mentioned, it's a cooperative effort primarily between the Forest Service and the county. The county is actually responsible for the burn operations, so they will be igniting the fire. They had their meeting, discuss the safety and the parameters which they can burn under to make sure that the burn goes well. Whenever we have a burn like this, we have a contingent of what we call holding forces, folks that are arrayed around the fire, both hand crews and engines. In the event that that fire goes beyond those barriers, we've got dozer lines, we've got a road up on the high side there. If that fire gets past any of those lines, those engines and hand crews are in place to immediately take action on that. So the county will be operating that, the burn, and then there's Forest Service and county resources here to hold that fire, basically. And then we've got a contingent of Forest Service folks and other folks that have an array of equipment out there, sensors and monitors and so forth, other cameras and different equipment. It's been a long time in coming. They've been doing this planning probably for about 2 years now to get everything. It's, like I said, it's a tremendous undertaking. When you've got these kind of conditions, anytime you have a fire, it's very dynamic. A lot of different things can happen, and they've got a lot of sensitive equipment in there. So that all had to be prepared and wired and then all protected from the fire itself as well. So it's been a tremendous amount of work to get things in place. You know, as Amber said earlier, our primary focus whenever we're engaged in fire suppression is safety for the firefighters. It's always our first primary objective. And so when you're looking at the dozers, it's those operators. When we have a dozer, there's also a person we call a dozer boss who's out there in front of that dozer. So finding out how best to protect those people. And then,
I think we've got our way.
yeah, okay. Yeah, he might be overhead for the rest of the time now.
Yeah. Get used to it. All right.
But that's part of our resources too, is our aviation assets. So the other thing, as Amber said, is more and more frequently we have fires in what we call the wildland-urban interface. As people move closer and closer to the forest or the national parks, if there's a fire that comes out of that park or forest or starts on private land or state land, our firefighters are called to help protect those homes. Very, very dangerous. You not only have the vegetation that's burning, but then you may have propane tanks and you got homes and all that other combustible material. So if we can protect those homes without having our firefighters there, then we increase the safety factor tremendously for those firefighters that at the same time help protect the homes or those other buildings that may be on Forest Service parkland. You know, it's going to be an interesting day, and any time you're working with fire, you really never know what's going to happen, but we do have some control. At least we're going to start this fire. We have some boundaries around where we know it's going to go. We're going to keep it in, but it's a great opportunity that could only happen because of all the cooperation from all these different folks out here.
As you can see from the actual footage of the fire swept right to left due to the wind. We had a great flame front on the front and the back as the fire actually took charge in the back of the panels. You could see some of the damage on the front of the material. However, the back of the material and the wood were undamaged on all of the panels so far. Although we don't have the numerical values, I think this test was a success. While the flame was approaching, I was a little worried that it would actually not touch the material. That was my only concern. However, it did, and all the materials held up fairly well. The one did get damaged, but it wasn't enough damage to cause damage behind it. Our team has actually learned, although we've known this from previous data, that aluminized materials work fairly well. It was further backed up by actual real-life data from an actual fire. Most of our tests so far have been all research, lab-related. The major surprise I had, I mean, this is my first fire, so that was a big surprise, but the eddy behind the material and behind the panels actually concerned me a lot because it was raging pretty heavily, and we expected most of the flame front to be in front of the panels. So that really surprised me. So far, I don't see any major material changes in the future. We might be going with lighter, more durable materials. And there was some damage to the aluminized materials before they were placed on the panels. So we're looking at possibly better aluminized materials. The next step to build a great fire blanket is, well, more testing, better materials, more durable, it would be great if we could have reusable materials. That way, if there was a flame front, it damaged it a little bit, but not enough to actually throw it out. That makes it more cost effective. And if you could easily deploy it, that helps a lot also. So we're looking at better deployment methods, more durable materials, and reusability. To summarize the actual burn, I think it went really well. We had great conditions. Although I don't have the actual numerical data, I think the flame temperatures were high enough that they were comparable to those fires in the wildland urban interface. So far I think this is successful. This fire was extremely beneficial to me because, as I said before, this is my first fire. I haven't actually seen a wildland urban interface fire before. We've collected a lot of great data. And we've also, gotten the experience of being out here with many different collaborators. And so overall, it's been a great experience. After we analyze all the data, it's back to the drawing board, which is located in Cleveland, Ohio at Case Western Reserve University.